Hi everyone, in the last video we talked about rules of exponents, so let's go through a number of examples simplifying using those rules. Now, this is actually a loaded word. When you see simplify in math, in this case, it means a few things. It means no negative exponents, it means no repeated bases. So we'll come up with that. I'll explain it more when we see it. Number one, negative 3 squared, but there's no parentheses with the negative, so this is really just saying negative, like invisible 1, and then 3 squared, so 3 times 3, so this is negative 9. This is different from number 2, where there's a parenthesis, so that means you are squaring what's in the parenthesis, so that's negative 3 times itself. And a negative times a negative is positive. So this one's positive 9. So please be aware of this distinction. If there's no parentheses holding the negative together with the number, it does not get squared. Number 3, you have negative 3 times itself 3 times. So negative times a negative times a negative is still negative. And then 3 times 3 times 3 is 27. Number 4, now this one, you have to remember your order of operations. Order of operations, exponents come before multiplication. So 3 times this quantity happens after I deal with the exponents. Exponents come first. So we have x squared raised to the 5th power. This is the power rule. So I have 3 on the outside still. And then according to the power rule, we multiply these exponents. And so this becomes 3 times x to the 10th. And if there was something I could do with the 3, like maybe if I knew what this base x was, then I would multiply by 3 after. For now, I just leave it just like that. And that is the simplified answer. Number 5. We have the 3 inside the parentheses this time, so it is going to get raised to the 5th power as well. So according to our rules of exponents, we have a product to a power. So this becomes 3 to the 5th times x squared to the 5th. And so you would want to use your calculator maybe, or do this by hand and figure out what 3 to the 5th is. So that is 243. And then same rule from before, we're going to multiply our exponents for the power rule. That's x to the 10th. Okay, so this one was different because the parentheses held the 3 together with the base. So it did get raised to the 5th power. And on the last one, the 3 was all the way outside in the front. Number 6, this whole quantity to the 0 power. So this one's fast. This is just 1. Remember, anything to the 0 power is 1, except 0 to the 0. Number 7, now we have multiplication here between these two factors, and so we're going to multiply and combine what we can. So it's a 5 times a 3, so that's 15. And then we have a y to the 4th times y squared. So this one is going to use your your product rule, and the product rule says that you add the exponents when the bases are the same and they get multiplied. So this is y to the 4 plus 2 power, so this is 15 times y to the 6th. Okay, number 8. Again, we're multiplying these two factors, and so we have negative 8 times 9. So that number becomes negative 72. We have 1m times m squared. And then we have n to the 6th times n squared. Okay, so right here we have the same base. So we're going to multiply the same base, which means we add the exponents. This becomes m to the 1 plus 2, which is m to the 3. This over here, same base, getting multiplied, so we're going to add the exponents. This is n to the 6 plus 2, so n to the 8th, and then we still had a 72 with a negative in front, and I spaced them out a little bit too much, but the n to the 8th, let me just squeeze it in right there, is right in there. So that is the answer. All right, number 9. This time we cannot just go straight into the multiplication. And think about why. Can you see why? The first quantity is raised to an exponent. This is unlike the last two we worked on. There was no exponent on the outside of the parentheses. So this time, our order of operations, we have to work on the exponent first before we can multiply. So before I do anything with the second term at all, I have to address this square, the second power. So this is -7 squared times a cubed squared times b cubed squared. All of that is just from the first parenthesis. I haven't even touched the second parenthesis yet. Then if we start simplifying that, let me just bring the second parenthesis down, quantity, so I know it's still there. I have -7 times -7, that's +49. Power rule, I have a to the 3 times 2, so this is a to the 6th. Power rule here, b to the 3 times 2, so b to the 6th. And now I'm multiplying, so now I can go ahead and multiply by this quantity in the back. So we have 49 times 7, so 343 in terms of our numbers. We have a to the 6th, I'll write this out so you can see the steps, times a to the 19th, and then we have b to the 6th times b to the invisible 1. And so right here, you add the exponents because the same bases are getting multiplied. So we have a to the 19 plus 6 power, so this is a to the 25th power. And then on the last part, we had b to the 6 plus 1. There's an invisible 1 if you do not see an exponent. So this is b to the 7th. And that is the simplified version of that expression. All right, let's get into some more. We're going to move over here. So number 10, notice you have a quotient and then it's raised to an exponent. So we have to deal with this exponent and see how it addresses the quotient. There's nothing to simplify inside because it's x, y, and z. They're not like terms. So we're going to go right ahead and use our quotient to a power rule. So this is going to be x squared y to the 4th squared over z squared squared. Now it sounds kind of funny. And then using our power rule, this becomes x squared. Over here, you multiply the exponents on y, so that becomes y to the 8th. And on bottom, you multiply the exponents for z over z to the 4th. And that one is simplified. Number 11, you have a negative quantity, a negative number to the 4th power. So right away, let's address the negative. Something negative multiplied 4 times turns positive. So that's going to just help me avoid having to work with this later. Now on the inside, I do have some options. I do have the same base on top and bottom. So you could work inside first and then bring in the 4th power, or you could actually bring in the 4th power now, but I'm going to go ahead and work on the inside first. And so just focusing on z, I have a z cubed on top and a z squared on bottom. And so according to our quotient rule, you can subtract. So this is z to the 3 minus 2, which is z to the 1. And if it's a 1, you can leave it off. You don't have to put the invisible 1. Another way to think about this is that there's 3 z's in the numerator, 2 z's in the denominator. And so 2 on bottom divided with 2 on top, leaving you with 1 z. And it's left on top because there's a positive 1 as the exponent. And so we have now, in the inside, the negative we already addressed. It was to the 4th power, so it turned positive. 2 to the 4th. Okay, so let me write it out. 2 to the 4th. X to the 4th. And then in the inside, all of this with a z was just z. Okay, so z to the 3rd over z squared was just z. So z to the 4th. And then the last thing to do, I wouldn't box this in because if I can find the number I need to, and 2 to the 4th we can figure out, that's actually just 16. So 16x to the 4th, z to the 4th would be the answer there. All right, a few more. They are getting a little bit more challenging. So on number 12 here, notice you have the same bases actually a couple of times. X on top and bottom, y on top and bottom. So part of simplifying is to not leave the same bases if you can simplify, which we can. So I'm going to separate this. I'm going to go ahead and say that this is x to the 12 over x to the 5th times y to the 13th over y to the 7th. You don't have to do this step. I just want to make it very clear, so I separated it to show you. Now, according to our quotient rule, we subtract. So this becomes x to the 12 minus 5, which is x to the 7th. And then over here, this becomes y to the 13 minus 7, so this is y to the 6th. And then these were getting multiplied, and so that's actually just the answer. So it's x to the 7th, y to the 6th. Okay, let's take a look at number 13. This has a lot going on. You have the same base on top and bottom in terms of a and b and c, and you also have negative exponents. So let me make this one a little bit more clear. I'm going to draw it or write it bigger because I do want to make it stand out. So I have 2a cubed b squared c to the negative 1 over a to the negative 1 b to the 5th times c. Okay, so on this case, I am multiplying, so I always just want to be aware. I am multiplying in between each of these factors, and then anything with a negative exponent is going to eventually move. So you can use the quotient rule at the beginning, or you can use the negative exponent rule at the beginning. Let me explain the difference really quick. So, two options for you, and this is really just what you decide you prefer to do. If you want to use the quotient rule, you would go right into this. You would say that I have 2 times a on top and a on bottom. If I'm multiplying, I can subtract. I would say 3 minus negative 1 for the power on a. B on top divided by b on bottom, this is going to be b to the 2 minus 5. And then c on top, and then c on bottom, this is negative 1 minus the invisible 1 on bottom. Okay, and then I would go from there. The other option is to move anything with a negative exponent first. So I could say that this is 2a cubed b squared on top, not addressing the c just yet because it has a negative exponent, b to the 5th times c on bottom, and then the a, because it has a negative exponent, is going to move up, and the negative sign comes off, and then coming back to the c on top is going to move down, and that negative sign comes off from the exponent. Either way here, we are going to get the same answer. So I'll work them both out, and then whichever one makes more sense to you is the one that I would say you should stick with. So back to the left side, if I start simplifying my numbers for my exponents, I have 2 times a to the 3 plus 1, which is 4. B to the 2 minus 5, which is negative 3. And then this is c to the negative 2. Okay. Now, both of these terms, or factors, have negative exponents, so they need to move. So the 2a to the 4th is okay. There's no negative exponents there. But the b and the c are technically in a numerator right now, since you don't see a fraction bar. They're in a numerator, so they're going to move down to a denominator, and when you move them, you take off the minus signs. Okay? And that would be the answer. So let's continue with the other method I showed and see that we're going to get the same thing. So over here, now you can use your negative exponent rule, or your quotient rule, and you would have the 2. Let's see what we have. We actually have a couple of rules. Let me rearrange. A cubed times a to the 1 on top. Then you have b squared on top, and then b to the 5th on bottom. I'm just kind of lining stuff up. And then we had c to the invisible 1 times c to the 1. Alright, all I did was rearrange. This step you could do without showing work. I just wanted to show it so you're not wondering what I did. Now I would use my rules for product and quotient. This is 2 to the times a to the 3 plus 1. b, because you are dividing, you're going to subtract b to the 2 minus 5. And then on bottom you are multiplying, so this is c to the 1 plus 1. Last step, simplify. This is 2 times a to the 4th. This is b to the negative 3, and then c squared. So because the negative 3 is here, I do have to do a final part where I bring the b to the denominator. 2a to the 4th on top, c squared, and then b to the positive 3 on bottom, which is in fact the same answer that we got before. So on this one, you can use your quotient rule first, or you can use your negative exponent rule first, and you will get the same answer. Number 14, you have a quantity to a negative exponent. And so right away on this one, I'm going to go ahead and use my negative exponent rule and say that this base that this negative exponent is attached to needs to move. So since it's not in a denominator, it's actually in an invisible numerator. There's like an invisible fraction bar here. So when I move it down to the denominator. The base is x to the 5th, and so now my minus sign comes off, and this becomes a positive 1 for a power. And then if there's nothing left on top, put an invisible 1. Okay, you write it. It was technically invisible to begin with. And then that's it. There's nothing really we can simplify here. So this is the answer. You could have used your power rule here as well, if that helps. If you see it better, this is 5 times negative 1. So this is x to the negative 5, which would get you right to this answer as well. Okay, last one. 10 times x to the negative 1. Notice that the x has a negative exponent, but 10 is not in a parenthesis, so it does not have a negative exponent. Y to the negative 3, and then y to the 5th. Okay, so what's going to happen here is I'm going to go ahead and address the y's first, and then the negative exponent on x. So right here, you are multiplying the y's, so you can use your product rule, and this is y to the negative 3 plus 5 power. So just this part with the y's is y squared. So now I have, let me rewrite it, 10 times x to the negative 1 times y squared. And now just the x has a negative exponent, so it's going to move. It's going to move to the denominator in this case. And so I have a 10y squared on top. X moves down, and the minus sign comes off. It's x to the positive 1. And because it's a 1 power, you could actually leave that off. You could erase that. And final answer. Okay, that's it.